Hello everyone. In this video, we're going to be looking at the 5 types of chemical reactions. Let's get into it. First things first, let's look at one of the more simple reactions, and this is called a synthesis reaction. Some textbooks may refer to it as a combination of reaction. It's really the same thing. The general equation of a synthesis or combination reaction is A plus B is going to equal AB, where A and B can stand for compounds or elements. And basically what's happening is that A and B are combining, they're synthesizing together to form a new compound. All right, so you can think of it as like addition in mathematics. And an example equation here is at the bottom. So we have calcium oxide combining and like synthesizing with carbon dioxide to form a brand new compound, which is calcium carbonate. And the same calcium from the calcium oxide goes here, and the same carbon from the carbon dioxide goes here. All right, so it's very straightforward. It's just elements, compounds combining together to form a new compound. And a quick way, if you want to determine it on a whim, is to see that if there's 2 compounds on the left side and 1 on the right, typically that is a synthesis or a combination reaction. All right. The next type of reaction that we have is kind of the opposite. You can think of it as the inverse of a synthesis reaction, and is a decomposition reaction. All right. And a decomposition reaction is when you go from a larger, more complex compound, and it kind of decomposes or breaks down into 2 or more elements or compounds, so A and B over here. And if you were to pay attention, you can tell that the synthesis is literally the backwards of this general equation here. So AB instead is going to turn into A plus B. All right. So an important note about decomposition reactions is that they're often catalyzed by heat or light. And if a decomposition reaction is catalyzed by heat, you're going to see this triangle over here, which signifies that it's a thermal decomposition. It's assisted by heat. And this is required in a lot of decomposition reactions. In this particular example over here, we have hydrogen carbonate thermally decomposing, so you can see the catalyst of heat here in the reaction, into water and carbon dioxide. All right, so the same hydrogens from here go into the water here, and the carbons from here go into the carbon dioxide here. All right, so that's pretty straightforward as well. The third type of reaction we have is a bit more complex. It's the single displacement reaction. And the single displacement reaction is a reaction where one element displaces another in a compound. So let's look at the general formula here. And here you have a bit of a unique one. It's A plus BC is going to equal AC plus B. Now what's happening here is that A, this element, is replacing C when it's with B. And then C kind of gets kicked out. Sorry, B gets kicked out. So A replaces B, and B gets kicked out and by itself. So a common connection that is made is with like maybe couples. So A is by itself and then B, C are a couple, and all of a sudden A comes along and then C likes A better, and then A and C are together while B is by itself. All right, and it's very important to note that for a single displacement reaction to actually occur, A is going to have to be more reactive than B. So A is more reactive than B. You can think of it, maybe it's more attractive than B. So then A and C end up together, and then B is by itself, and it's very sad. All right. And another important note is that A and B have to be the same type of substance. So it has to be a metal and a metal, right? Or a non-metal and a non-metal. All right, so A would not be able to replace C because C is likely a non-metal, right? So I will explore this in the examples here. Actually, it's probably the best way to do it. So here we have, in the first example, we have magnesium over here on the side, and you have copper nitrate. And what's happening is that copper is a metal, but magnesium is the more reactive metal. So nitrate finds magnesium more attractive, you can think of it that way, and it ends up together, and while copper is displaced, right? So copper has to, and this only happened because magnesium and copper are both metals, and magnesium is more reactive. Magnesium doesn't kick out nitrate because nitrate isn't a metal. All right, so that's important to note. And the second example, it also shows you how this could occur with nonmetals. So here, A takes on a nonmetal. It's chlorine here, right? Chlorine in its diatomic form. and this is sodium bromide. And what happens here is that nonmetal, sodium is the metal, this is the nonmetal in this instance. So if you look at the activity series, chlorine is far more reactive than bromine. So what's going to happen is sodium is going to find it more attractive. Sodium and chlorine end up together, and then bromine is kind of by itself, right? And since it's by itself, it's going to have two. That's how diatomic elements work. All right, and just as a side note, these little coefficients here, these are just to balance equations. They're not significant, extremely significant to the actual nature of the reaction. All right, so hopefully that made sense. Next, we're going to be looking at double displacement reactions, and this is a bit more interesting. Double displacement reactions are reactions that occur between two ionic compounds. That's very important. They're always between ionic compounds, and you'll often see them in aqueous solutions when they dissolve into ions. So that's typically when you'll see them. It's important to note that they're between ionic compounds. All right, and what's happening is that these ions are exchanging places. So if you look at the general formula here, you have AB and CD turning into AD and CB. What actually happened? It's just these switch place, right? The D came over here, the B came over there, and then they switched partners. You can think of it as dancing, maybe. You switch partners in dancing. So A is now with D, and then C is with B. All right, and it's just so this whole reaction is a really fancy way of exchanging ions. And the example we have here is potassium carbonate over here and calcium chloride react. What happens? These are going to switch places, right? Now you have potassium chloride and you have calcium carbonate. All right, so it's just these ions that switch places. The reason why they switch places is because these reactions typically occur in aqueous solutions where like the ions dissolve, so they become like individual ions, and they can rearrange themselves in new ways. All right, now the fifth type of reaction that's classified as a separate type of reaction in some textbooks are called combustion reactions. And combustion reactions is when substances, usually hydrocarbons, react with oxygen in a way that releases a lot of energy. So it's heavily exothermic, if you know what that means. But you can just think of it right now as it's a lot of energy is released in these reactions. These are the chemistry gone wrong kind of reactions that you see on the internet. And hydrocarbons are derivatives of carbon and hydrogen together, and sometimes oxygen as well. And they're natural substances that are often burned. And what happens is that they combine with oxygen, and then if it's a complete combustion, it's going to produce carbon dioxide and water. A complete combustion will always produce carbon dioxide and water, right? And the amount of it is just dependent on, how you balance the equation. All right. If it's an incomplete combustion, and this is when there isn't enough oxygen mostly, it produces carbon monoxide, and it can also produce soot, which is just plain carbon. All right, so a complete combustion, just don't worry about it. You know it's going to be carbon dioxide, water. Incomplete combustion, you're looking at carbon monoxide and carbon too. We'll go into more depth about this in a later video, so stay tuned for that. But the example problem I have here is CH4 methane, a very simple hydrocarbon derivative, combining with oxygen. And as you said, this is going to be a complete combustion, so you're going to have carbon dioxide and water. These coefficients just balance the equation. All right, so in this video we looked at the different types of chemical reactions. We looked at synthesis reactions, decomposition reactions, single displacement reactions, double displacement reactions, and combustion reactions. If you enjoyed the video, please click the like button. Consider subscribing to the channel, and I hope to see you guys soon.